According to NEC 1984, Section 430.95 Service Equipment Capacity, Paragraph A rating, service equipment must have sufficient capacity to handle the maximum load as determined by Section 220.10. Section 220.10 Branch Circuit, Feeder, and Service Calculations, Paragraph A continuous load, states that the continuous load shall be the sum of the continuous loads of the circuit supplied. There is an exception that applies to dwelling units, stating that the continuous load for feeders and service entrance conductors supplying one dwelling unit shall be permitted to be calculated in accordance with Table 220.10. Table 220.10, Paragraph B dwelling units, provides demand factors based on the number of bedrooms. For service entrance conductors supplying one dwelling unit, the minimum permitted total demand load shall be as determined in this table. The table then correlates the number of bedrooms to a demand factor, such as one bedroom having an 80% demand factor, 2 bedrooms having a 75% demand factor, 3 bedrooms having a 70% demand factor, and 4 or more bedrooms having a 65% demand factor. Based on the provided information, the continuous load is 600 amps, which is less than the ampacity of the service entrance conductors, which is 750 amps. Therefore, according to Section 430.95, Paragraph A, the service equipment, specifically the 1000 amp circuit breaker, has sufficient capacity to handle the maximum load. It is generally recommended to have the service equipment rating slightly higher than the ampacity of the service entrance conductors to allow for future load growth or unexpected increases in demand. However, when the required continuous load is significantly lower than the ampacity of the service entrance conductors, the larger circuit breaker is acceptable according to the code. It is advisable to consult the latest version of the NEC for the most up-to-date information on electrical requirements. The 2023 NEC is the current version, and it may have additional provisions or clarifications on this topic. To reiterate, the code mandates that service equipment can handle the calculated load according to Section 220.10. Since the 600 amps continuous load is less than the 750 amps service entrance conductor ampacity, the 1000 amps circuit breaker satisfies the basic requirement. The NEC aims to ensure safety and prevent overloading of electrical systems. Matching the breaker size to the conductor ampacity is a crucial part of this. The choice of overcurrent protection, like a circuit breaker, must protect the conductors from overheating. Therefore, a breaker larger than the conductor ampacity isn't typically permitted unless specific conditions are met. In this scenario, the 1000 amps breaker is larger than the 750 amps conductor ampacity. However, the actual load is only 600 amps continuous. NEC permits some flexibility when the load is significantly less than the conductor ampacity and breaker rating. Firstly, the primary concern is protecting the conductors. The 750 amps conductors can safely handle the 600 amps continuous load. Secondly, the 1000 amps breaker provides a level of overcurrent protection, even though it's higher than the conductor ampacity. This setup works because the actual load is substantially lower. The NEC requires service equipment to handle the maximum load as per Section 220.10. This section dictates how to calculate loads for various applications. The key consideration is whether the load is continuous or non-continuous. A continuous load is defined as a load that operates for 3 hours or more. Continuous loads require special consideration in load calculations. For continuous loads, the NEC requires the load to be multiplied by 125%, meaning the circuit must be rated for at least 125% of the continuous load. In this instance, the continuous load is 600 amps. If this load is indeed continuous, the circuit must be rated for at least 600 amps times 1.25, which equals 750 amps. Since the service entrance conductors are rated for 750 amps, they meet this requirement. The 1000 amps breaker, while larger than the conductor ampacity, does not violate this requirement because the conductors are adequately sized for the continuous load. It is important to consider future load growth. While the current load is 600 amps, there is a possibility the load may increase in the future. If the load increases significantly, the 750 amps conductors may become undersized and the 1000 amps breaker may trip unnecessarily. It's advisable to assess the potential for future load growth and choose conductors and breakers accordingly. The NEC contains tables that provide ampacity ratings for various types of conductors. These tables take into account factors such as conductor material, insulation type, and ambient temperature. It is critical to consult these tables to determine the appropriate conductor size for a given application. The NEC also addresses the issue of conductor termination temperature ratings. Conductors are typically rated for 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. The termination points of the conductors, such as circuit breakers and panel boards, also have temperature ratings. It is important to ensure that the conductor temperature rating is compatible with the termination temperature rating. In general, the conductor ampacity must be based on the lowest temperature rating of the conductor or its termination. In some cases, it may be necessary to use a larger conductor size to meet the termination temperature requirements. The NEC provides specific rules for sizing service entrance conductors. These rules take into account the total load connected to the service, as well as any applicable demand factors. Demand factors allow for a reduction in the calculated load based on the assumption that not all loads will be operating simultaneously. The use of demand factors can result in a smaller service entrance conductor size. However, it is important to apply demand factors carefully and to ensure that the calculated load is sufficient to meet the actual demand. The NEC also addresses the issue of short circuit current rating, or SCCR. The SCCR is the maximum short circuit current that a component or assembly can withstand without failure. It is important to ensure that the SCCR of all components in an electrical system is adequate for the available fault current at the service entrance. The available fault current is the maximum current that would flow in the event of a short circuit. If the SCCR of a component is less than the available fault current, the component may fail during a short circuit, potentially leading to fire or explosion. The NEC provides guidance on how to determine the available fault current and how to select components with adequate SCCR. In summary, while the 1000 amps breaker exceeds the 750 amps conductor ampacity, it is potentially acceptable given the 600 amps continuous load and adherence to NEC guidelines specifically regarding conductor protection and load calculations. Consulting the latest NEC version and considering future load growth is crucial for ensuring a safe and compliant installation. It's also important to ensure that all components have adequate short circuit current rating.